Michelle, we're going to go live with your presentation. This is Michelle Crook. Michelle is going to speak on the Michigan State's Conservation Agency that's developed new technology for addressing small farm milk house water heater treatment systems, dark blood filter mounds, and some new technology coming out of Michigan. Michelle, are you on?
I'm on. Can you hear me okay?
Take it away, Michelle. Very good. Thank you.
Okay, great. Thank you. As you said, I'm going to talk about a system we've been working on for quite a while. We call it our bark bed filter mound, and the goal is to treat milking center wastewater from small and medium-sized dairies. This is a problem that was brought to us back in 2003 by one of our ag extension agents who was concerned with a lot of our small and medium-sized dairies and how they were able to handle their milk house wash water. About 90% of the dairies in Michigan are less than 200 cows, so this is a big problem for us. What we're looking at treating is the residue coming out of the milk center along with some manure and food-grade cleansers that gets in there. We're not looking at treating when there's a bulk tank of milk that needs to be dumped, although the systems have had to handle that because pretty much every farm we've installed it on has accidentally dumped an entire tank of milk into it at one time or another. And you know, this wastewater doesn't have any economic value for the farm, so we really needed to find some type of system that would work. Traditionally, what they have been doing was, if they had liquid manure storage, they could include it into that system, but if they did not, that obviously didn't work. Conventional septic systems had a high failure rate and were clogging, which caused most farms to disconnect it and run a pipe to the ditch. And to do a daily haul during the winter, that was not a very doable operation for them. It was very labor intensive. So in 2004, NRCS, along with our Department of Environmental Quality, Department of Agriculture, and Michigan State University, we developed a work group, which is now referred to as our wastewater work group, to look at treatment technologies. We've seen a lot of disposal technologies for handling this type of material. We really wanted to look at what we could do to treat it. And the two areas we focused on were constructed wetlands and filter mounds. I'm going to focus on the filter mounds. We actually are still working on the constructed wetland aspect and getting very close on that. Expect to have a practice statement probably within the next year on that area. Some of our partners involved in this were the Clinton County Conservation District, our Department of Environmental Quality, Michigan Milk Producers was a big partner, along with Farm Bureau. What we were looking for was some type of system that would function year-round, that wouldn't be cost prohibitive and would be low maintenance, that met some of our environmental challenges that we have. Michigan has very unique groundwater regulations, which were a big hurdle at that time in dealing with this type of system, and we needed to find something that would meet the regulatory agency's requirements so that NRCS could put a standard in place. We also needed a system that would be compatible for those that wanted to continue to manage their manure as a solid and provided treatment. Like I said, we didn't just want disposal. The filter mound system appeared to meet these requirements, so we decided to start a testing protocol to evaluate this. This gives you a schematic. Sorry, I know it's a little blurry, but that was our initial blueprint from way back when that we started with, and we don't have nobody has an electronic copy floating around anymore. If you're familiar with home systems that would use a pressurized mound distribution system, we based this off of that. We did a very similar operation, except for we were using bark as our media instead of a sand as would be used in a home situation. One of the goals for that was to keep down odor and to avoid clogging issues. This gives you an idea of what the overall system, this is our very first pilot system, ended up being about 8 feet across, 5 feet high, with a total width of 18 feet at the base. Not really an attractive system, but you usually can stick it in a place where it's not too big of an eyesore. For our initial project, we were looking at a farm that produced about 1,000 gallons per day of milking center wastewater. the area we were distributing it on was 3,000 square feet, and the goal was to pump each of the areas consistently and allow resting periods in between for the media to recover. And we dosed it at a rate of 0.33 gallons per square per day, similar to what you would do for a home pressure round system. This gives you a little idea of the layout on the existing farm. You can see right here we have 4 tanks we put in. We put in 4 in that was because this was an experimental system. We wanted to have some flexibility in case it did not function as expected. And then we also had to run our distribution pipe from the tanks over to the sections, working around the scales to avoid causing problems for the farm. And the wife wanted it set back out of the way where she didn't have to look out the window at it. So we were able to fit it into a rather small site with some limitations. One of the problems we did find out later is the areas where we put the mound, what had been a loafing area for a significant number of years, and there was no sign of that when we were on site, but that had caused some compaction that wouldn't have been ideal if we were to go back and redo it at this location again. We also wanted to test some different media types. One of the concerns with the bark was bark, of course, is going to break down. There was discussion early on that the farmer is going to need to go in and change out the bark on a regular basis, which can be labor intensive, and we were trying to avoid that. So we also looked at wood chips and a styrofoam chip. Styrofoam chip ended up being a dismal failure, to say the least, and we replaced that later with pea stone, so we were actually able to test a total of 5 medias. And we also did the bark aerated and non-aerated, and this is just a passive aeration, putting tubes underneath just to get more air into the center of the pile. This shows you the layout of the 4 tanks we initially put in. We have the water flowed into an additive tank to begin with. This allowed us the flexibility if we decided we needed to add some kind of polymers later on to increase settling. We didn't end up doing that and have not added any polymers to date. From there it flows into 2 settling tanks. These are both filtered to remove a lot of the solids, and from there it goes from the pump chamber and where it can be sent over to the system. This shows the pipe layout before the final cover went on the top. You can see these metal fence posts we put in. We originally had propped up the system. We found that to be unnecessary as well. We went away from that. We have made some other changes to help with this, with settling. You're going to get some settling of the bark over time. This shows the sequencing valve that sends it. You can see the 4 pipes coming off of that, sends it to doses each of the 4 sections of the mound at different times. And that just gives you a close-up of it. It sprays up out of the pipes and into the covers to distribute it evenly across the bark surface. And you can see in the background to the left the styrofoam chips we were trying initially. Like I said, we were hoping those would work because they obviously wouldn't break down, but they did not, and we would not recommend trying media like that again for this type of material. And this shows you the pressure head we had on the lines at the ends of them. That's always tested before we cover up the system to ensure we're getting even distribution throughout the system. And we try to get between 3 and 5 feet ahead at the end of the lines. And as well, we have clean out ports at that point so that when you do get solids or you get biomass built up in the lines, you can go back through and flush them. But we're able to flush them out pretty easily. We don't get a whole lot of biomass buildup in the lines. Our research system at the time cost $31,000. That was with bark at $10 per cubic yard. Now approximately $16 cubic yard. But we had a lot of testing aspects that went into our initial system, soil lysimeters and the such, so that we could grab samples. And so we expect a non-research system would typically be about $30,000 for a 1,000 gallon per day capacity. We operated the initial system for a total of 34 months. As I said, we made some changes along the way as we learned things. And did a variety of monitoring on it. This shows the location of the lysimeters. We tested at 2 feet below the distribution lines, at the soil and bed interface, and then 2 feet below the soil surface. What we found from our sampling was that the bark was very effective for treating for nitrogen, phosphorus, E. coli, COD, and TSS. Removed about 90% of all of those parameters. The wood chips, it was marginal, not a strong treatment media, and the styrofoam and pea stone was very ineffective. It did still provide some disposal, but did not provide the treatment we were hoping to gain. We also found that over a 3-year period, we had minimal bark breakdown. We did not have as much as we'd initially were concerned about. We recommend from the study that for the settling tanks, we'd have 3 to 4 times your daily wastewater volume available. As I mentioned earlier, we've got some unique groundwater regulations in Michigan. Metals leaching from high BOD wastewater being applied to the land surface is a concern for our water quality agency. And at the time we were doing this, they had wanted us to show that we were getting no metal leaching. As the project went on, which took longer than it should have because of this issue, it was realized that we weren't creating any additional problems over what a conventional septic system would be, and those were allowed under the regulations. So DEQ did agree that yeah, this did provide a better option than a conventional septic system that we would expect to fail, and so they decided that this would be an acceptable alternative for Michigan and agreed to putting a standard in place. Some of the big concerns: regular maintenance. That's really important. Preventative maintenance, pulling the screens, rinsing them off, flushing the lines. Also, a qualified contractor on board. We used a contractor who is very familiar with traditional home septic systems, even though he had never done work of this type before, but his knowledge and experience was really, really valuable. This shows you a little bit of how much settling we did get over the 3 years' time that we were operating the system. Like I said, it was minimal right after the dosing chamber. We also did have some manifolds that the settling caused to come apart. We've gone to a flexible manifold in those locations so that where it's connected to the distribution pipe, we have that flexibility and the settling won't cause the breaks. This is one of the filters that was in the system. We did end up with some clogging. With this system in particular, it was kind of interesting. The farm actually went to increased the number of milkings. So they pushed this system past what its design point, pushed it to the point of failure. They also were having some issues with cleaning out their milking center, which was they were getting hair into the filters. As a result of that, we've also modified the type of filter. We've got a filter that's a little more hardy, I think, a little more appropriate, and recommend cleaning out the milking parlor sump after every 9 to 12 milkings. That really has made a big difference. This gives you an idea of some of the maintenance that's required. The typical monthly maintenance is pretty short, pretty quick. You can do all that on a reasonable basis. You do get into some of the larger ones, such as pumping out settling tanks, getting any of those solids out once a quarter. That does take the better part of a day, and replacing the bark, which is we have estimated every 4 to 5 years that will need to be replaced, and it's about a 12-hour job. What we wanted to do after testing of this one is put in a couple more systems to see how it worked on some other farms. We went to the phase 2 of our project. We actually picked out 2 different farms. One was very well organized, very conscientious, communicated well with us. The other one was financially not in a very good place and was challenged. And of course, as a result, Farm 1 still has a system that's operating great. Farm 2, the system wasn't. We were actually out there doing a fair amount of maintenance on the system for the farmer, and he since sold the cows, so that one did not continue to operate. We looked at some of our our findings from the past design. We adjusted it for these new farms, as well as looking at some different sample and collection parameters. This gives you an idea. We did a different layout with this farm. We actually did all the beds next to each other instead of end to end. That's also something we would not necessarily recommend again. Being able to get that aeration along the sides of the system gets more air into the system and provides better quality treatment. This does still provide treatment, but just not as well as our initial system. So overall, we do feel this design works. We have put a standard in place working with NRCS. We have not launched that standard as a statewide, go in and install it wherever you want. We're doing them on a case-by-case basis with cooperation between Department of Ag and Rural Development and NRCS, and going out and doing site visits on everyone that is proposed by our local offices to see if it's a suitable site, make sure that they've got good soils, and doing a lot of hand-holding on these initial systems as we get them up and running. But the practice is pretty easy to understand. You know, farmers are typically familiar with septic systems, so they're generally pretty comfortable with it. And that's the end of my slides.
Thanks, Michelle. Nicely done.